Hi, welcome to math class. Today we're going to be doing lesson 3 in topic 1. The last lesson we did was lesson 2. And in lesson 2, we learned how to tell the difference between rational and irrational numbers. Today we're going to use what we know about the square roots of perfect squares to estimate the value of the irrational numbers that are square roots of non-perfect squares. So we're going to start out, again, we're on page 20. We're starting out by looking at a flag, and we know that the width of the flag is 7 feet, and the height of the flag is 5 feet, and we're supposed to figure out what the diagonal of the flag is. So in order to do that, we need to estimate because we do not know what the square root of 74 is. Here is what we do know. We know that 74 is smaller than or less than 81, and I chose 81 because 81 is a perfect square. We also know that 74 is bigger than or greater than 64, and I chose 64 because 64 is a perfect square. So when you're trying to approximate an irrational number that's under a radical sign or a square root sign, you choose the perfect squares that are just a little smaller than that number and a little bigger than that number. And then what you do is you square root everything. So the square root of 74 is less than the square root of 81, and it's bigger than the square root of 64, which means that the square root of 74 is in between 8 and 9. Now, the next question we need to answer is it closer to 8 or is it closer to 9? Well, since 74 is closer to 81, 81 minus 74 is 7, and 74 minus 64 is 10. So 74 is closer to 81 than it is to 64, which means that the square root of 74 is going to be closer to 9 than it is to 8. So you find a number line and you place it just like that. The next example, example 2, is similar. This time we're going to compare the square root of 32 to the number 5.51326 ... So we're now comparing two irrational numbers. So again, we will do the same thing with the 32, square root of 32, that we did with the square root of 74. So 32 is in between the two perfect squares of 25 and 36, which means that the square root of 32 is in between the two perfect squares of 25 and 36. So the square root of 32 is in between 5 and 6. 32 is closer to 36 than it is to 25. So we want to know approximately what that value is. So we can just try it out. 5.5 times 5.5 is 30.25. 5 and 6/10 times 5 and 6/10 is 31 and 36/100. So we're getting closer. We're trying to get to 32, remember. Here, 5 and 7/10 times 5 and 7/10 is 32 and 49/100. Closer yet. And here we have 5 and so we know that this is in between, okay? So we're looking for 32. This is pretty close to 32. This is a little bit smaller than 32. So the square root of 32 has to be in between these two numbers. Okay, now if we're comparing to this number here is smaller than this number here, which means that 5.51326 ... is to the left on the number line, and the square root of 32 is to the right. Now, for example 3, we have several numbers that we're supposed to organize. So we have some work to do. We're not using a calculator. Of course, you're at home. If you're using a calculator, that's up to you. You will not use a calculator on the test. At least that's the plan. So here are the numbers we're supposed to deal with. So I'm going to convert as many of them to decimals as I can. So 9.8 is already in decimal form. So I'll leave that. Let me get so 9.8, we'll put that right here. And 9.5 repeating, we'll put that here. There might be something in between those two. We don't know that yet. And let's see here, what else do we have? 9.5. So that takes care of 3 of them. And all we have to do is estimate the square root of 94. So the square root of 94, well, 94 is in between 81 and 100. Those are the two perfect squares that are on either side of 94. And if we square root both sides, or square root everything, I should say, we find out that the square root of 94 is in between 9 and 10. It's closer to 10 than it is to 9. So again, we do a quick check. And if we take 9.7, or 9 7/10, and times 9 7/10, so 7 times 7 is 49. 7 times 9 is 63, plus 4 is 67. And then we need a 0 to hold our place. Get rid of this. 9 times 7 is 63. 9 times 9 is 81, plus 6 is 87. And then if we add these up, we have 9, 0, 1, 9. Sorry, need a 4 there. That's pretty close to 94. So it's about 9.7, and 9.7 goes right here. So we'll just, let's write square root of 94. Let me undo that here. Square root of 94. And then the next thing we have to do is we have to square pi. So somewhere here we need to find room to work. Let me erase this here. We'll multiply 3.14 times 3.14 and see where that fits in our list. So let's see here. So 3 and 1400ths, that's the approximate value of pi, times 3 and 1400ths. 4 times 4 is 16. 4, 5. And we need a placeholder. 1 times 3, 14. And we need 2 placeholders this time. 3 times 4 is 12. And then we get 6, 9, 5, 8, 9. And so you can see that pi squared is just a little bit bigger than 9.8. So here's where we want to put, whoops, excuse me. Here's where we want to put pi squared. I better get a different color so it shows up. Pi squared. So that took a little bit of work. That didn't go quickly, but that's what you need to do.